In this module, we'll discuss about random variables and probability distribution, and we will mainly focus on discrete probability distribution. As I was saying, in this module, we will focus on discussing random variables, especially what are the difference between the discrete random variable and continuous random variable. Then we'll move to probability distribution, and our today's focus on this lecture will mainly be on discrete probability distribution, and then how we can calculate mean and variance for discrete probability distribution. Let's first start with the discussion of random variable. So what do you mean by random variable? For a random variable, the value of the variable depends on the random outcome. As for example, say height of the student in a class. So if you choose different student, then the height of the different student would be different, right? Therefore, it is a random case, right? Therefore, the height of the student would be a random variable, and the random variable could be like discrete or continuous. So let's look into the example of discrete random variable. As for example, the number of heads in 3 coin flips. So if you randomly flip a coin 3 times, then how many number of heads could appear? It might happen like in 3 draws, in 3 throw, like the number of head is 0, or it could be 1, it could be 2 or 3, right? It cannot be more than 3, right? Since you are flipping the coin 3 times, and it also cannot be less than 0, because it might happen like head didn't come like once, so it could be like 0 to 3, right? Or similarly, let's look into a continuous like random variable. As I was saying, like the height of each student could be a continuous random variable, or temperature in a room could be a continuous random variable, right? Because it could take like any value. But on the other hand, for discrete random value, it will just take the isolated value, right? As for example, like number of heads if you flip a coin 3 times, or number of defective item in a bus, or number of cars passing in intersection in an hour. So here all the numbers are discrete, right? I think now it is clear to all of you like what is random variable and what is the difference between discrete random variable and continuous random variable. Now let's see some example and try to see whether we can identify the discrete random variable and continuous random variable. So here the first variable is time of a student to register for the fall term, whether it is a discrete random variable or continuous random variable. It is a continuous random variable, right? Because this time could be anything in minute or second, right? Or so. And the second example is number of text received on a random day. So it will always be an isolated number, right? It will always be a discrete value. Therefore, in this case, the random variable is a discrete random variable. Let us look into some more example. As for example, here, the miles driven by a car after the full charge for an electric car. So it is obviously a continuous variable, right? Because it could be anything. It could be say 320 mile or 320 .1 mile, 320.5 mile, or it could basically take any values, right? And the values are not discrete, therefore it is a continuous random variable. And the voter turnout, like from the 50 registered voters, so in that case it's obviously a discrete value. It will always be a discrete value, right? Therefore the random variable associated with this case is a discrete random variable. I think now it is clear to all of you like what is the difference between continuous random variable and discrete random variable. So let's discuss about some of the properties of the discrete probability distribution. So the probabilities are always in between 0 and 1. This is true for all probability distribution, whether it is discrete or whether it is continuous. Then some of the probabilities for all the events will be always equal to 1. And since it is a discrete probability distribution, so it will only take countable values or integers, right? Now let's look into an example. Say here we are rolling a die. So if we roll a fair die, then what are the possible outcomes? The possible outcomes are 1, 2, 3, 4, 5, and 6. And each of the outcomes, since it is a fair die, so each of the outcomes are equally likely. And the probability for each of the outcome would be 1 over 6, since in total we have 6 outcome, and each of the outcome has equal probability. Therefore the probability would be 1 over 6 in that case, and we can write it like in the table like that. So here what are the possible outcomes? 1, 2, 3, 4, 5, and 6, and that is the probability associated with each outcomes. So the probability associated with 1 is 1 over 6, the probability associated with 2 is 1 over 6, and so on, right? The probability here is same for all the events, right? So this is a probability distribution, this is a discrete probability distribution, right? Let's talk about the sample space now. We have talked about sample space in one of our previous lesson, but let's talk about that once again. So sample space is the collection of all possible outcomes for a random variable. As for example, say if we are talking about throwing a die, then what are the possible outcomes? So the possible outcomes are 1, 2, 3, 4, 5, and 6, right? Therefore, the collection of all of those would be our sample space. And for a coin flip, what are the possible outcomes? Head or tail. Therefore, the collection of head and tail would be our sample space for coin. And say in a quiz test, there are 4 MCQ questions, and then what could be the score of a student? The score could be anywhere between 0 and 4. Therefore, the collection of 0, 1, 2, 3, 4 would be the sample space in that case. So now I think it is clear to all of you what do you mean by sample space. So let's talk about this problem once again. We have seen for a die throw, like those are the outcomes. Like for a die throw, we have the outcomes 1, 2, 3, 4, 5, and 6, and the associate probabilities are those. Like the probability for 1 would be 1 over 6, the probability that 2 will appear is 1 over 6, and so on, right? Now if somebody asks you like what is the probability that if you throw a die then at least 3 will appear, right? At least 3 will appear. That means it could show 1, it could show 2, or it could show 3. Then what you have to do, you have to take the sum of probability that die will show 1, or the probability that die will show 2, or the probability that die will show 3, right? And what are the probabilities? What is the probability that the die will show 1? 1 over 6. What is the probability that die will show 2? 1 over 6. What is the probability that die will show 3? 1 over 6. Therefore, what you have to do, you have to just take the sum of these 3 probabilities, and that basically give you 3 over 6, right? Which is 0.5. So the probability that if you throw a die, then at least 3 will appear is 0.5, right? So now somebody can also ask you like if you throw a fair die, then what is the probability that more than 4 will appear? It will show more than 4, right? So more than 4, that means it has to show either 5 or 6. And what is the probability that the die will show 5, 1 over 6? What is the probability that die will show 6, 1 over 6? And if you take the sum of these two, it would be 2 over 6, which is like 0.333. That means if you throw a die, there is 33% chance that you will get more than 4, or in other words you will get 5 or 6, right? Similarly, if you are asked like if you throw a die, then what is the probability that at least 5 will appear? So at least 5, that means it could show either 1, 2, 3, 4 or 5, right? And if you take the sum of all of this probability, you will get this number, right? Now we know that we have discussed that the sum of the probabilities for all the events associated with a probability distribution is 1. So we can do one thing, to get the same probability. How? Let's see. So we are asked, like, what is the probability that at least 5 will appear, right? That means we know that total probability is 1, and if we subtract the probability of like die will show 6, then basically these two things are the same thing, right? Probability that at least 5 will appear, at least it will show 5, is same as 1 minus probability that the die will show 6, and it will basically give us the same number. Here we can see like 1 minus, what is the probability that the die will show 6? 1 over 6, right? And that basically is the same number. We call that complement. So at least 5 is the complement that the die will show 6, right? And these two will basically give us the same number. Now let's discuss how we can calculate the mean or expected value for a probability distribution, or variance for a probability distribution, and then finally standard deviation. So to calculate the mean for a probability distribution, what we have to do? We have to take these values and their corresponding probabilities, and we have to take the sum over all of the possible outcomes. Then it will give us the expected value or the mean. And similarly for the variance, what we have to do? We have to take the square distance of the value from the mean, and then we have to multiply that with their corresponding probabilities, and we have to do that for all of the values, and then if we take the sum, that will give us the variance. And similarly, and for standard deviation, we know that standard deviation is simply the square root of the variance. Therefore, to get the standard deviation, we just have to take the square root of the variance, and that will give us the standard deviation. Now in the next slide, we'll see with the example how we can calculate mean and variance, and finally standard deviation with an example. So in our previous slide, we have discussed the formula for expected value or mean for probability distribution was that. So now let's see how we can calculate that. So here for a die throw, we have the outcomes 1, 2, 3, 4, 5 and 6, and those are the associate probabilities. Now to calculate expected value or mean, what we have to do? We have to multiply these values with their probabilities. So 1 times 1 over 6 is 1 over 6, then 2 times 1 over 6 is 2 over 6, then 3 times 1 over 6 is 3 over 6, and so on. Then what we have to do? We have to take the sum of all of this number, and that will give us the expected value. So if you take the sum of all of this, finally the expected value that we get is 3.5. And what does that mean? That means the mean or the expected value of rolling a fair 6-sided die is 3.5, right? Now let's see how we can calculate variance. So the formula for variance is like that. So now let's see how we can do that. So what we need, we first need to we'll take the difference of mean from each values, and earlier we have seen in the previous slide that the mean, if we throw a die, then the mean value is 3.5. So now we have to subtract 3.5 from each value. If we subtract like from 1, if we subtract 3.5, then this is like negative 2.5. From 2, if we subtract 3.5, which is negative 1.5, and so on, right? And then what we have to do? We have to take the square of those values. So if you take the square of these values, you'll get this number. Negative 2.5 square is 6.25, negative 1.5 square is 2.25, and so on. And we already know about the probabilities, right? Associated probability with this number. Then what we have to do? We have to multiply this number with the corresponding probabilities. So that give us those value, and finally we have to take the sum of all of this value, and that will give us the variance. So here therefore the variance and the here therefore the variance would be finally 2.92. And how we can get the standard deviation from the variance? We simply have to take the square root of this value, and if we take the square root of this value, that give us 1.71. I think now it is clear to all of you like how for a discrete probability distribution we can calculate expected value or mean or and variance. Now let's look into another problem. So here we have the number of pet information for families, and the family can have here for this problem can have from 0 to 3 pets. So some of the family can have 0 pets, some of the family can have 1 pet, some of the family can have 2, and some of the family can have 3 pets. And what are the associated probability with that? The associated probability with that is 0.4, 0.3, 0.2, and 0.1. So what does that means? What does that is number means? And here okay, by the way, one thing I need to discuss before that. So here the like all the cases the sum of the probabilities has to be 1 all the time, right? So first you have to check whether the sum of all of this probability is 1 or not. And here if you take the sum of all of this probability, it is 1. That means it is a probability distribution. If the sum of all the probabilities is 1, that means it is a probability distribution. Now what are those number basically means? It means like 40% of the family doesn't have a cat, right? So it doesn't have a pet in their family. And what does that mean? That means 30% of the family has only one pet in their family. 20% of the family has two pets in their family, and 10% of the family has three pets in their family, right? I think it is clear to all of you like how we can basically interpret an probability distribution, right? Now we'll see how we can transform the raw data to a probability distribution. As for example, here we have the test score result of 100 student for 4 MCQ questions. So for 4 MCQ questions, then the possible score could be like 0, 1, 2, 3, 4, and in total we have 1000 student, and 50 students like their score was 0 in the test. For 150 student their score was 1, for 300 student their score was 2, and so on. So in total the number of student is 1000. So in total the number of student is 1000. Now in the next slide we will see how we can transform this information to a probability distribution. So in the earlier slide we have discussed like we have this information, we have the score and we have the number of student corresponding to the scores, right? The test scores. And now how we can convert this to probability? So we can basically use relative frequency, right? So here we have to take the count and then we have to divide by the total number of student. So here then the probability associated with this would be like 50 over how many student? 1000 students. So 50 over 1000, which is like 0.05, then 150 over 1000, which would be like 0.15, and so on. So now the information that we have here is probability, right? And if you take the sum of all of this probability, it should be 1, right? It would be 1. Therefore now it is a probability distribution. So now we can see like how we can transform the raw data into a probability distribution. So now let's see how we can interpret that, how we can interpret this probability distribution. So as I was saying earlier, like to be a probability distribution, the sum of all the probabilities has to be 1. So if you take the sum of all of this probability, that must be 1, and here you can see it is 1. Therefore we can tell that we have successfully converted that to a probability distribution, right? So now how we will interpret this result? So what does that mean? Here the corresponding probability for G associated with 0 is 0.05. So what does that mean? That means like 5% of the student in the test has scored 0, right? And here the number 0.15 means 15% of the student in the test just score 1. 30% of the students in the test score just 2, and 35% of the student score 3, and so on, right? I think the interpretation of the probability distribution is clear to all of you now, right? So if you want, we can also convert this probability distribution in a histogram like that. So here we have the raw score, raw test score, and here we have the probabilities, right? So what percent of the student, what was the probability associated with 0? It was 0.05. So here the height would be 0.05. Then what percent of the student? 15% of the student score only 1, and the probability is 0.15. Here you can see the height is 0.15. Then 30% of the student score 2, and here you can see the height corresponding to score 2 is 0.30, right? And so on. And in that case the total area would be 1, right? Since this is a probability distribution, so the total area would be 1. So this is the way basically we can transform the probability distribution, and we can present that in a graph as well, like that. If you understand the probability distribution, that help us to take a lot of decision like very easily. As for example, you decided like in the test, if anybody scores below 2, then probably this student need extra help. Then you can decide like what percent of the student basically score below 2, right? In that case, what you have to do, you have to just take the probability of the student who scores either 0 or 1. And what was the probability associated with that? The probability associated with 0 score was 0.05, and associated with the score 1 was 0.15. So together that is 20%, right? So that means like 20% of the student in the class score below 2, and that means like 20% of the students probably need some extra help in this course, right? Now with an example, we'll see how we can use probability distribution for practical case. As for example, here, say one of the industry has a product, and they also use some advertisement for this product. And here we have the information like how many times the buyers check the advertisement before buying the product. So some of the buyer check once, some of the buyer check twice, and so on. So here 27% of the buyer check the advertisement once, 31% of the buyer check the advertisement twice, and 18% of the buyer check the advertisement thrice before buying the product, right? And now we'll see how we can calculate mean and variance for this program, for this problem in the next slide. So how we can calculate calculate the mean and standard deviation for this problem? So first we have to convert the percentage into probabilities, and then we can find like the average exposure before purchase, right? And we basically will use probability distribution formulas to do that, and we'll discuss in the next slide how we'll do. So here we have the number of times the buyers will check the advertisement before purchasing the product, and here we have the associated probability. We have converted the percentage into probability, and then what we have to do to calculate the mean, we have to multiply this number with their associated probability, and that is the number that we get. And then we have to take the sum of all of this number, that will give us the mean, right? And then to calculate the variance or standard deviation, what you have to do to calculate the variance, we have to subtract the mean from each of this number. So what was the mean here? Mean was 2.54. So we have to subtract this number from all of this number. So from 1, if we subtract 2.54, then that is negative 1.54. Then from 2, if we subtract 2.54, which is negative 54. And then from 3, if we subtract 2.54, which is 0.46, and so on. So then, according to the formula for for variance, if you remember, we have to take the square of that, right? So then we'll have to take the square of these numbers, or square of these numbers, and that give us those numbers. And then finally, we have to multiply those numbers with the corresponding probabilities of this column. And if we multiply those numbers with the corresponding probability, that finally give us this number, and we have to take the sum of all of these numbers to calculate the variance. And then to convert this variance to a standard deviation, we have to just take the square root of this, and that will give us a standard deviation. That means on an average, before buying a product, the buyers check the advertisement 2.54 times with variance 1.87, right? I think now it is clear to all of you, like how for a probability distribution we can calculate mean and variance. So what we have learned in this lesson, we have learned what is sample space. Sample space is the collection of all possible outcomes for a experiment try. And then we have discussed in details about the probability distribution, and we have mainly discussed about the discrete probability distribution in our today's lesson. And then we have seen in the real world application, like how we can use probability to take decision, and we can calculate expected value and variance for probability distribution, right? Thank you everyone. See you in the next lesson.